Hello learners! This is Teacher Arnel and I will be your teacher in physical science. I hope you are all doing well and ready to learn from this topic. Are you ready now? Then let's begin! Objectives. At the end of this video lesson, learners are expected to 1. Describe the general types of intermolecular forces. 2. Determine if a molecule is polar or nonpolar given its structure. And 3. Relate the polarity of a molecule to its properties. Before we start our discussion, let's have a review quiz. You need to prepare paper and ball pen. Are you ready? Let's start. Multiple choice. Choose the letter of the correct answer. 1. It is a theory that explains that the universe started as a very dense and hot singularity which eventually cooled and began to form different particles. A. Big Bang theory. B. Cosmic inflation theory. C. Oscillating theory. D. Steady state theory. Number 2. The process by which light nuclei fuse together to form a heavier nucleus. A. Nuclear fusion. B. Nuclear reaction. C. Nuclear synthesis. Or D. Nucleosynthesis. 3. The process that creates new atomic nucleus from pre-existing nucleons, primarily protons and neutrons. A. Nuclear reaction. B. Nuclear synthesis. C. Nucleosynthesis. D. Nuclear fusion. 4. What was formed as the universe expanded and cooled down? A. Subatomic particles. B. Electron. C. Proton. D. Neutron. Five. What is formed when there is a fusion of a proton and neutron and Big Bang nucleosynthesis? A. Deuterium. B. Hydrogen. C. Protium. D. Tritium. Time is up. Put down your pen. And be ready for the answer key. Now these are the answers. 1. Letter D. 2. A. 3. D. 4. A. 5. A. So that is the answer key for our review quiz with a total of 5 points. Did you get 5 points? Wow! Congratulations! Now, I think you are all ready for our next lesson, the intermolecular forces. Have you seen these things in your everyday life? Did you ever ask yourself, why do droplets of water stay on the surface of the leaves? Or have you ever wondered why ice cubes float in a glass of water? How about wondering why do we need dishwashing liquids to clean the plates? Soap to clean our laundry? Why not just water? Or why are we using shampoo to clean our hair? Intermolecular forces are the forces of attraction or repulsion which act between neighboring particles like atoms, molecules, or ions. And these forces are weak compared to the intramolecular forces, such as the covalent or ionic bonds between atoms in a molecule. Hydrogen bonding is a special type of dipole-dipole attraction that is very strong. It occurs when nitrogen, oxygen, or fluorine are bonded to hydrogen. Question. Using periodic table of elements, calculate the electronegativity for HCl or hydrochloric acid and H2O or water. Since HCl, which has an equivalent electronegativity of 2.9 and 2.1, which has a difference of 0.8, while H2O or water has an equivalent electronegativity of 3.5 and 2.1, and its difference is 1.4. The high electronegativity of NH, OH, and HF bonds cause this to be strong forces, about 5 times stronger than normal dipole-dipole forces. They are given a special name, H bonding, because compounds containing these bonds are important in biological systems. Consider two water molecules coming close together. The positive hydrogen is so strongly attracted to the lone pair that it is almost as if you were beginning to form a coordinate bond. It doesn't go that far, but the attraction is significantly stronger than an ordinary dipole-dipole attraction. Let us discuss this. What determines if a substance is a solid, liquid, or gas? Now, shown the image, there's a gas, a liquid, and a crystalline solid. Now, in gas, total is order, much empty space, particles have complete freedom of motion, particles far apart. While in liquid, disorder, particles or clusters of particles are free to move relative to each other, and particles are close together. While in crystalline solid, ordered arrangement, particles are essentially in fixed positions, and particles are close together. As you can see, in gases, the average kinetic energy of the gas molecules is much larger than the average kinetic energy of the attractions between them. While in liquids, the intermolecular attractive forces are strong enough to hold the molecules close together, but without much order. Now, in solids, the intermolecular attractive forces are strong enough to lock molecules in place or high order. Next is the ionic bonding. It is where the forces holding ions together in ionic solids are electrostatic forces. Opposite charges attract each other. And these are the strongest intermolecular forces. Ionic forces hold many ions in a crystalline lattice structure. Next is the London forces. When we say London forces, it is where non-polar molecules do not have dipoles like polar molecules. London forces are named after Fritz London, and it is also called van der Waals forces. London forces are due to small dipoles that exist in non-polar molecules. Because electrons are moving around in atoms, there will be instances when the charge around an atom is not symmetrical, and the resulting tiny dipoles cause attractions between atoms or molecules. Dipole forces. Polar covalent molecules are sometimes described as dipoles, meaning that the molecule has two poles. One end of the molecule has a partial positive charge, while the other end has a partial negative charge. The molecules will orientate themselves so that the opposite charges attract principle operates effectively. Now, for the intermolecular forces. Intermolecular forces are attractive forces between molecules. They are largely responsible for the observed boiling points and solubility properties of molecules. While the physical properties of melting point, boiling point, vapor pressure, evaporation, viscosity, surface tension, and solubility are related to the strength of attractive forces between molecules. So these attractive forces are called intermolecular forces. The amount of stick togetherness is important in the interpretation of the various properties listed above. There are four types of intermolecular forces. Most of the intermolecular forces are identical to bonding between atoms in a single molecule. Intermolecular forces just extend the thinking to forces between molecules and follows the patterns already set by the bonding within molecules. You can use the scale below to identify the type of bond. It is ionic if the electronegativity difference is greater than or equal to 2.0. It is polar covalent if the electronegativity difference is 0.5 and not less than 2.0, while it is nonpolar covalent if the electronegativity difference is less than 0.5. This is a chart for electronegativity values of the elements according to Pauling scale. You can use this as a guide to identify the different types of intermolecular forces. Okay, let's go now for our evaluation. So the direction is, using the periodic table below, determine the kind or kinds of intermolecular forces that are present in each of the following elements or compounds. Choose your answers below. The options are dispersion forces only, dispersion and dipole-dipole forces, or dispersion force, dipole-dipole forces, and hydrogen forces. You have 5 minutes to finish this activity. You may start now. Time is up. Put down your pen and be ready for the answer key. It's time for us to check now. Okay, for number 1 answer, it's dispersion force. For number 2, dispersion force, dipole-dipole, and hydrogen bond. Number 3, dispersion force. Number 4, dispersion and dipole-dipole. Number 5, dispersion force. For number 6, dispersion force, dipole-dipole, and hydrogen bond. Number 7, dispersion and dipole-dipole. Number 8, dispersion and dipole-dipole. Number 9, dispersion and dipole-dipole. And for number 10, dispersion force. The perfect score is 18. Who got 18? Congratulations! For your assignment, answer the question below using your own words in your notebook. Number 1. Why do you use water to rinse the plates or clothes with dishwashing liquid or soap? Number 2. Submit a picture showing you are washing dishes or clothes in group chat account. That is the beauty of intermolecular forces. I hope you learned from this topic, and don't forget, stay on school. Stay at home and keep safe and keep on learning. Thank you for watching.